Let's go ahead and check another problem about the enthalpy change. We have 200 cubic centimeter, 0.15 concentration hydrochloric acid is mixed with this volume and this concentration of sodium hydroxide. The temperature rose by this value if both solutions were originally at the same temperature. Calculate the enthalpy change of neutralization. They're already telling you that you are supposed to calculate the enthalpy change of neutralization. Okay, we have to first of all to say that delta H neutralization is equal to, it's always exothermic reaction, negative Q over N. What is Q? It is MC delta T, then all over N is giving us delta H. Do we have M? As we have agreed before, M for neutralization reaction should be the volume of acid plus the volume of base. Where's the acid? Here is hydrochloric acid. Where's the volume of the acid? It is 200. So 200 cubic centimeter plus 100 cubic centimeter. One of you will tell me how come you're using volume when you're calculating mass. We agreed before that it is a valid assumption because density is equal to 1. So we have here 300 cubic centimeter or 300 grams. What is C? C is for water 4.18. What is delta T? Delta T is given here. It is 1.36 degree Celsius. Then we have here number of moles. What is the number of moles? As we agreed before, we have to have an equation for the neutralization reaction. What is the neutralization reaction equation? We have here hydrochloric acid. What is hydrochloric acid? It is HCl. What is the base? It is NaOH, sodium hydroxide. What should be the product? It is salt, NaCl, plus water, H2O. We have to make sure that our equation balanced. Okay, it is balanced. Then we can simply calculate the number of moles of water based on what? Based on the mole ratio with the acid or base. What we have here, HCl. What is number of moles of HCl? We have here V and C. So a number of moles should equal, N is equal to C by V. Do we have C? Yes, it is 0.15. Do we have V? Yes, V is 200, but we have to care about the unit here. It is cubic centimeter, and what we have in the concentration is cubic decimeter. So we have to have it 200 by 10 to the power negative 3. Then we will get number of moles. If you put these numbers in the calculator, you will get 0.03. Using the mole ratio, HCl is 1, H2O is 1, so the mole ratio is 1 to 1, so the number of moles of water produced should equal to 0.03 moles, okay? 0.03 moles. One of you will tell me, should we calculate the number of moles of NaOH from the volume and the concentration? Yes, we are supposed to do that. Why? Because maybe we have a limiting reactant here. So, but if we calculate it here in our problem, you will find that the number of moles of NaOH based on the data given here, it is 0.03 moles. So we do not have, both of them are equal to each other, and the mole ratio is 1 to 1, so it is okay. But whenever you have acid and base reaction, it's always recommended to find the number of moles of acid and number of moles of base. Maybe you have a limiting reactant, so take care about that. But in our problem here, we have the same mole ratio 1 to 1 and the same mole ratio with water 1 to 1. So the number of moles of water are equal to the number of moles of acid or base calculated. So the number of moles here for water is 0.03 moles. Okay, then everything should be clear now. So delta H, if you put these numbers in the formula here, you will get this number, negative 5,690 joules per mole. Okay, we can divide by 1,000 to get this number, 56 6.9 kilo joule per mole. Okay, that's it.